Welcome back to class. So today we're going to look at what climate models can tell us about the future of Earth's climate, in particular what they tell us about the average global temperature. So models that have been used, for example, in the experiments I showed you last time to try and predict what the climate looked like in the past can also be used to look at what the climate of the Earth will look like in the future. But it's a little more tricky because the future can look very different based upon what we do. For example, the human population is a large determinant of what the climate may be. For one, more people tend to produce more greenhouse gases. But the future can also differ in the kinds of energy resources we use. And so given the differences that can occur, the Intergovernmental Panel on Climate Change, the IPCC, has come up with several scenarios for the future. And that's what's pictured here. There are 4 scenario groups, which are pictured by the 4 branches of this tree. And the inputs into those branches are the human population, the global economy, the development of technology and how it's shared, importantly, across countries, what kind of energy we're using, and agriculture and how land is used. So the 4 scenarios are essentially divided up in terms of economic development. So the A scenarios, in those scenarios, economic development tends to be more prioritized over protecting the environment. And in the 2 scenarios, development tends to be more regionalized versus in the 1 scenarios, development tends to be more global in scope. So when you make these assumptions that all have inputs in these areas and you put them onto climate models, you get different answers about what's going to happen to the climate. And that's what this graph shows. So let's have a look at this graph. So this is from the 4th assessment report of the IPCC. That was from 2007. And their baseline year is 2000. And what you see here is an orange line. That's the constant composition commitment. That's essentially meaning that if we didn't put any more greenhouse gases into the atmosphere, the temperature would still warm a bit by 2100. But of course, that isn't going to happen. So let's look at the B1 scenario. So the B1 scenario, remember, is a scenario in which population is limited in growth, that economic development is not prioritized above environmental protection, and that the development of new technologies is shared globally. And in that scenario, which is in some ways the best case scenario, we're still looking at about 2 degrees Celsius of warming, or about 4 degrees Fahrenheit. In the A1B scenario, and that can be thought of as sort of a business as usual scenario, which is to say population growth is going to continue as expected and technology development will occur, but there won't be a massive transition from fossil-based fuels to alternatives. We're looking at somewhere between 2 and 3 degrees Celsius. In the A2 scenario, global population does not peak around mid-century. It continues to grow. There is massive economic development, and it is not done in a terribly sustainable way. We're looking at 3 to 4 degrees. The main point I want to make about this graph is that based upon the choices we make, we can have a tremendous effect upon what happens to the climate of the Earth in the future. The difference between the B1 scenario and the A2 scenario is 2 degrees of Celsius warming on average, and some of you may say, well, 2 degrees Celsius, what's the big deal? But it turns out that that actually is an enormous deal for what is at stake for our health looking forward into this century. And I want to make one case as to why that is so. So here's another graph that shows the temperature on Earth going back millions of years, but I want to focus your attention on the last 10,000 years or so. So before 10,000 years, there was an ice age, and that ice age ended and the climate warmed. From the Younger Dryas, it warmed about 5 degrees Celsius. And then we entered into the current climate period. And the current climate period, called the Holocene, is important for many reasons, but one of which is you'll notice that the temperature during the Holocene has essentially been within 2 degrees Celsius throughout that time. So we're talking about raising the Earth's temperature by another 2 degrees. And the question is, what happens to the planet's systems in a world in which there's 2 degrees more on average of warming? Well, one of the systems that is important to pay attention to is agriculture. So this is a picture of emmer wheat, which is the first grain one of the first grains that was cultivated on Earth. And the melting of ice after the last ice age enabled the establishment of agriculture in the Fertile Crescent. And it was only with the melting of ice that agriculture really was able to take hold anywhere, because much of the planet was covered in ice. So if you look at this slide, this is a picture of what the Earth's surface was covered with at the last glacial maxima, at the end of the last ice age. You'll see that most of North America, most of Europe, large parts of Asia was under ice. And just to give you a visual of what that looks like, this is a picture of the White Mountains of New Hampshire today. And this is what that scene might have looked like 15,000 years ago. It would have been covered in ice. In fact, it was probably about 1 kilometer of ice that would have covered it. So only in the last 10,000 years or so has agriculture been possible over large parts of the Earth. And what's important about that is that all human enterprise depends upon agriculture. So my ability to be a pediatrician and deliver this lecture to you is possible because there are people who are able to grow food for lots of other people. Before agriculture, everyone had to get food on their own. So in some ways, agriculture is the innovation that enabled all others. So as we move into a climate that is unlike any in which we've had to do agriculture before, one of the questions we have to ask is, what is possible for the production of food for agriculture as the climate warms? So this question about what climate change means to food production is one among several that we will address in coming lectures about what these changes in the Earth's climate mean to our health. But before we get to those, I want to turn to some of the arguments that have been put out there to suggest that the climate science community has got it wrong. That in fact, the evidence that I put forward, which is only a small fraction of the overall body of evidence that supports greenhouse gases contributing to warming, is in fact not right. And that's what we'll turn to next time. See you then.